Yeah, it's audible.
I'm trying to share my screen, sir.
Yeah,
Sir, is my screen visible to you?
yes, it's visible.
Okay, sir. So, good afternoon, everyone. My name is Amit Kumar. I am from Andhra University. So, at the outset of my presentation, I would like to thank the organizers of 4th International Conference on Communication and Intelligence Systems, which is being organized by the NIT Delhi, in order to give me this wonderful opportunity to present my paper entitled Cloud-Based House Price Predictor App Using Machine Learning. So, the contents in my study are as shown in this slide. The first section is the introduction, the second one is the literature review, the third section is the research methodology, the fourth is the results and analysis, while the fifth is the conclusion, and finally there are references which are used in this study. So coming to the introduction part, a large part of economic growth it is driven by housing investment, and the availability of better data permits more precise estimates of house price in both developing as well as developed countries. So an accurate estimation of any housing property it is very much important to both sellers as well as buyers, as a fair deal will be struck in between them. So a real estate sector's profits these are directly related to the price of the house and lands, thereby setting the right price it is very much essential. So basically there are two methods in order to assess the value of the house. The first one is the hedonic method, while the second one is by using machine learning techniques or the artificial intelligence techniques to predict the price of the house. So the objectives of my study are as shown in this slide. The first objective is to analyze the application of machine learning based computational intelligence for predicting the price of house in Boston region using different independent variables. The second objective is a comparison of the performance of the results of all the machine learning algorithms used in this study for predicting the price of the house. And finally, the third objective is to develop and deploy a cloud-based computer application which can be used by anyone in order to predict the price of the house. So the data set which I have used for this study is downloaded from Boston Houses Prices data set, and it basically consists of 14 different attributes. And the data set, its different 14 different attributes are as shown in this slide. So the first one is the crime, that is per capita crime rate. The second one is the residential area zoning of land cover. It's a continuous value. The third one is the Indus area of non-retail place. The fourth attribute is the Charles River. It's a dummy variable, and if a house is beside the river, then it is coded as 1 or else it is coded as 0. The fifth attribute is the concentration of nitric acid. The sixth attribute is the average number of rooms. The seventh attribute is the age of the property. The eighth attribute is the distance from the Boston Employment Center. The ninth attribute is the radial highways accessibility index. The 10th attribute is the property tax per 10,000 US dollars. The 11th attribute is the ratio of students to teachers by town. The 12th attribute is the percentage of blacks in a town, while the 13th is the low status population in percentage, which is denoted by LSTAT. And finally, the 14th attribute is the dependent variable, which is the median value in thousands in US. It's a continuous value. So basically the data set, it contained about 506 observations as shown in this slide with 14 different attributes. And during the pre-processing process, I have found that there were no null values as well as no duplicate values in these data sets. Thereby it was a very clean data. So the workflow of my study is as shown in this slide. So initially the housing data has been downloaded, and then the exploratory data analysis of this data set, that is say the correlation matrix and different probability distribution functions I have built for the independent variables. And the data in the data pre-processing step, I have plotted the box plots as well as distribution of different independent variables. And then in the next step, I have divided the data set into two different parts. That is 80% of the data set is used for training, and the rest of the data set is used for testing. And then different machine learning algorithms has been trained and tested on this data set. Finally, based on the accuracy, the highest accuracy achieved by the particular machine learning algorithms, I have used that particular machine learning algorithm in order to develop and deploy an app which can easily predict the price of the house in the Boston region. So coming to the exploratory data analysis part, as shown in this slide, I have built a heat map, a correlation matrix which shows the relationship between all the dependent as well as the independent variables. And here we can see the LSTAT, that is lower status of the people, it is highly negatively correlated with the median value, that is the dependent variable of the this data set and average number of rooms, it is highly positively correlated with the target variable, that is the median value of the house. So the median value of house as well as the LSTAT, it has been plotted by a scatter plot, and here in this diagram we can see that there is a negative correlation between these two variables, and hence we can interpret that as the LSTAT, that is the lower status of the people, it gets increased, the median value of the house, it gets decreased. So the next thing which I have done is that I have built a scatter plot for average number of rooms as well as the median value of the house, and here we can see that there is a positive correlation between both of these variables. Thereby we can interpret it as the number of rooms, average number of rooms get increased, obviously the median value of this house also it gets increased. So in the data preprocessing method, I have plotted a box plots in order to identify the outliers, and here I have found that the variables such as crime, the residential area zoning ZN, as well as the black, it had many outliers in this data set. Thereby what I have done is that I have normalized this data using the log transformation techniques. So the next thing which I did was I plotted the distribution of all the independent variables, and I found that variables such as crime and distance from the Boston Employment Center DIS, it were leftly skewed, which is shown in this orange color circle figure, as well, and the age and the age of the building and the black, all these two variables, they were somewhat rightly skewed. So the variables like Indus, radial distance as well as tax, it has a double bells, and the rest of the variables, they were uniformly or say normally distributed in this data set. So as for variables, that is crime, zone, tax as well as black, they were not uniformly distributed. What I did was I normalized all these variables using min-max normalization techniques. So in the next step, I divided the dataset into two parts, as I have said earlier. 80% of the dataset was used for training dataset, while the 20% of the dataset was used for testing dataset. And the machine learning algorithms which I used for this study were the linear regression. The first one was the linear regression, the second was the decision tree, the third one was the random forest, the fourth one was the extra tree regression, and finally extreme gradient boosting regression was used in this study. So, I mean, coming to the methodology, all the giving an overview for all the machine learning algorithms would be highly impossible for me due to the time constraint. But I would like to give an overview of two different machine learning algorithms used in this study. So the first one is the linear regression. Basically, what exactly linear regression does is it explains the relationship between the dependent as well as the independent variable with the equation y is equal to mx plus v for a simple linear regression. So then it tries to fit a best fit line between the actual as well as the predicted value, and the cost is the error in our predicted value, which is usually calculated using mean squared error. So the goal of this linear regression is to minimize this cost function as much as possible in order to find the best fit. And cost function here, it is given as 1 upon n summation of I is equal to n yi minus y hat whole square. So this is the cost function of this linear regression. This can be the estimation of m as well as c, it can be done using two or three different methods. The first one is the OLS, that is ordinary least square method. The second one is the gradient descent. So in my case, I have used gradient descent algorithm, which finds the best fit line for all the given training data set whenever it's having a small number of iteration. So here we can see the cost function gets plotted against the m. Sorry.
Allotted time, so please conclude.
Yes sir. So at a particular point MSC, M and C, it tries to calculate where the MSC is very much ideally 0 or very much small. So due to time constraint, I would like to skip the methodology part. And coming to the results as part, the accuracy comparison of all the models which is used in the study, it can be shown as shown in the table 2. And finally, extreme gradient boosting regression XGBoost, it outperformed all the machine learning algorithm in this study with a least number of MSC as well as cross validation score. So the feature importance using XGBoost. So the XGBoost, it gives most important to the variable LSTAT, which is the lower status of population, and the second important variable in order to predict the price of the house was the average number of rooms, and the third was the nitrogen oxide, and so on and so forth. So the outlook of the app, which I built, it looks like this. So using the extreme gradient boosting regression. So the same thing, I would like to even show you in a real time demo by simply entering the data of all these input variables, And finally, if I click on the predict button, then this app simply it predicts the value of that particular house, value of the house. So give me 2 seconds, in order to enter this input values. And finally, if I hit the predict button, then this app, it predicts that the particular this particular value of this house would be $25,000. So coming to the conclusion part, this paper has made an attempt to predict the price of the house in the Boston using different machine learning algorithms. So an exploratory data analysis of the data set was done, and few of the outliers which were not uniformly distributed, it were normalized using min-max method, and using the correlation matrix, the highly correlated variable was dropped in order to avoid the multicollinearity problem. And based on the result, XGBoost outperformed all the models. Thereby, this particular machine learning algorithm was used to build this app. And additionally, the performance of the models could also be increased if we tune the hyperparameters and create some new attributes in the model. So these are the few of the references which I have used in this study. So if anyone is having any queries, then kindly let me know.
Amit, very nicely, very impressive work.
Thank you, sir.
Very. What is your size of data set?
So the size of the total number of observation is 506 observations, sir.
Other novel techniques like
sorry, sir, I cannot hear you properly, sir.
Hello.
Yes, sir.
Very nice work. Very nice work.
Thank you, sir.
Good.
Thank you.
That's all from my side.
Amit?
Yes, ma'am.
Why did you want to choose your XGBoost algorithm? Did you try any other ensemble learning methods?
Actually, madam, yes, madam. Actually, there were no study wherein XGBoost Regressor was used as of now, madam. So this is one of the reasons which I use this machine learning technique, madam. And since this extreme gradient boosting regression, it outperformed all the machine learning algorithms. What I did was I used this algorithm in order to develop as well as deploy the app, because this gave me the best results, madam. I can even build the app using linear regression or the decision tree, but as far as the accuracy concerned, XGBoost Regressor, it gave me the best accuracy. Thereby, I have used this model, madam.
Okay, so what is the loss function for your XGBoost function algorithm?
Sorry, madam. Last.
What is the loss function that you have used?
Function, madam.
Loss function.
Oh, loss function, madam.
Yes.
Yeah, actually, that is given in the my paper, madam. So yeah, for the linear regression, the loss function was this was the loss function, madam. M is cost error. 1 second. Yeah, here if you can see this yi minus y hat whole square 1/n summation of I is equal to, and this was the loss function, madam, for linear regression. For the extreme gradient boosting regression, the loss function is given in the total research paper, madam. So due to the time constraint, I could only explain the linear regression, madam. I even skipped the random forest model too, madam.
It's okay, your work was good. Maybe you can try improving the existing algorithm. Sure. Like you can write your own code to improve your XGBoost algorithm. Yes, change your loss function or change your any other activation functions, so you can come up with your own algorithm, which would be better.
Sure. Thank you, madam.
Thank you.
Thank you, sir. Still, whether you are facing that issue?
Now we're able to fill it.
Okay. So, anyone else want to ask any question?
No.
Okay, so next, yes. Yeah, next I would like to call
37.
Yeah, paper ID 37 and the author Tyagi, Bhavana, Nigam, Swati, Singh and Rajiv.
Good afternoon, sir.
Yes.
I hope my screen is visible.